1.7, this is our simplifying radicals. So a couple of things we need to think about is talk about the term factor pairs. What are factor pairs? So factor pairs of 6 are 1 and 6 and 3 and 2. Those are the numbers that you can multiply to get the number 6. So if we're looking at these factor pairs of number 24, okay, we have some calculator instructions right over here. You're going to go to y equals. You're going to type in the number divided by x, and then go to second graph, which is the table, and then you can write out the factor pairs, all right? So if I'm going to take a look at 24, all right, I'll just go right over to my calculator. I'm going to go into y equals, and I'm going to type in 24 divided by x. And your calculator is just going to generate a bunch of those numbers. So 24 divided by 1, 24 divided by 2, 24 divided by 3, okay? And that's going to give you the factor pairs. So see, the factor pairs are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. All right, so then you can list out the factor pairs just right here. 1 and 12, 1 and 24, 1 and 24, 2 and 12, 3 and 8, and then 4 and 6. Those are all the numbers that multiply together to get you to 24. So again, if we try with 128, let's try the factor pairs of 128. I'll go back to y equals. I'm going to type in 128 divided by x, which is 1 divided by 1, divided by 2, divided by 3. Go over to your table and check it out, and you're going to see 1 and 128, 2 and 64, 4 and 32. All right, so let me start that. So 1 and 128, 2 and 64. And then let's see here, we had 4 and 32, and then 8 and 16. So 4 and 32, 8 and then 16. And then let's see if we have any more. No, that's about it. 16 and 8. You see it kind of repeats and you know that you're done right there. Okay? So then go ahead and take a look. What are the factor pairs of 96? What are the factor pairs of 96? So I go back to y equals, clear this out, and I'm looking at 96. I'm going to divide by x, and then I'll let the calculator do the work. All right, so what are the factor pairs? 1 and 96, 2 and 48, 3 and 32, and 4 and 24, 6 and 16. All right, so we got a lot of factor pairs there. So 1 and 96, 2 and 48, 3 and 32, 4 and 24, so 3 and 32, 4 and 24, and then 6 and 16, and then 8 and 12. See how it repeats? That means we already got it, right? 8 and 12. So 6 and 16, and then 8 and 12, 6 and 16, and then 8 and 12. So all these numbers multiply up to give you 96, okay? Now, it's important to do that because what we're going to do, we're going to simplify the square root of 24, all right? So what is the square root of 24? So on our calculator, we could just type that in our calculator to see here, right? Second x squared, I get the square root of 24. There you go, hit that button. And you see it's an irrational number, meaning it's a non-terminating decimal. These decimals don't ever stop. And 4.8989, right? 4.898 rounded to the nearest hundredth. This 8 right here is going to make the 89 go up to a 90. That'll be rounded to the nearest hundredth. Think of hundreds because it's got 2 decimal places because there's 2 zeros there. Okay. Now, if I move over here and look at what is radical 24 written in simplest radical form here, well, let's look up here. We already found the factor pairs of 24. We've got 1 and 24. We've got 2 and 12. We've got 3 and 8 and 4 and 6. So 3 and 8 and 4 and 6. Now out of these numbers, which one is a perfect square, right? And we should know by now that 4 is a perfect square, and it's the only one. So what we're going to do here is I'm going to rewrite 24 as the square root of 4 times the square root of 6. I'm using that factor pair right here. Now, if I simplify, the square root of 4 we know is 2, and then radical 6 cannot be simplified any further. You can break it down to 2 times 3, but neither of those are perfect squares. So that's why we say that this is in simplest radical form. Okay, now let's check out 128. What are all the factor pairs of 128? Well, we looked up here. I've got 64 is a square root. I've got 4 as a square root. I've got 16 also has a square root. There are 3 numbers that we use. So the idea here is you want to use the largest perfect square. So this would be the factor pairs that I would use. So if I go down here, I would write the square root of 64 times the square root of 2. Because I know the square root of 64 is 8 radical 2. There we go. And let's go ahead and take a look at the square root of 96. Now, 96 also has a lot of factor pairs, right? So what are the perfect squares? Well, let's see if we can find one. And here we've got 16. There it is. It's the only one. So this is the factor pairs that we'll use. When you're simplifying this radical, I would break this down to the square root of 16 times the square root of 6. And the square root of 16 is 4. So 4 radical 6. So you can see in your calculator, if I type the square root of 96, I'm going to get that. And if I also type 4 radical 6, I'm also going to get the same exact number because they are equivalent. And the last thing you need to do is, if you don't know what the perfect squares are, if you're struggling to remember them all, just type in y equals x squared. And what that will do in your table will list all of the perfect squares in the output. See, you got 4, 9, 16, 25, 36. It'll list all of them right here. So if you're taking a test or you're not sure, you want to list them out on the top, you can just list out all those numbers. Okay? All right, y'all. Good luck.